Welcome to the Laplace transform. So definition, the Laplace transform of a function f of x, sorry, of ft, is a function which we will denote by f of s with a capital F this time. Or sometimes we'll write this as a fancy script L of lowercase f of t. So this is a Laplace transform of lowercase f of t. And this is defined by capital F of s is equal to the improper integral from 0 to infinity of e to the negative st times f of t dt. So note we're integrating with respect to the variable of the initial function. The variable of our final function s is just acting as a constant within the integral. So for example, let's go ahead and find the Laplace transform of our basic constant function f of t equals 1. So in this case, then the Laplace transform of that lowercase f of t is equal to capital F of s, which is the integral from 0 to infinity of e to the negative st times 1 dt. So we would take the limit as capital T goes to infinity of the integral from 0 to capital T of e to the negative st dt. As long as s does not equal 0, this is just equal to the limit as t goes to infinity. We would do negative 1 over s times e to the negative st evaluated at 0 and capital T. So this is for s not equal to 0. Or taking the limit as capital T goes to infinity of negative 1 over s times e to the negative s times capital T. And we would minus a negative 1 over s times e to the 0th. So this has a couple different things happen. If s is greater than 0, then e to the negative st will go to 0. And so we'll just have, this is 0 plus 1 over s. If s is less than 0, then e to the negative st will blow up. We'll actually have growth. And so this would be a case where we're looking at infinity plus 1 over s. And so we would have that the Laplace transform is just equal to 1 over s for s greater than 0, or infinity for s less than 0. And then we have our one case we threw out when s is equal to 0. I need to give myself just a little more space. So looking at our last case, if s equals 0, then we have just the integral from 0 to infinity of e to the negative st would just be e to the 0th times 1 dt. So we're just looking at the integral from 0 to infinity of 1 dt. And this, of course, is also infinite. So essentially what we get is the Laplace transform of 1, so f of s, which is just the Laplace transform of 1. This is equal to 1 over s for s greater than 0, and otherwise it's undefined. So we can use this improper integral to figure out the Laplace transform. We can do it for a variety of functions. We're going to go ahead and do one more. Let's go ahead and find the Laplace transform of f of t equals e to the at. And here we're going to go ahead and do f of s is the Laplace transform of e to the at. This is the improper integral from 0 to infinity of e to the negative st times e to the at dt. So here we're looking at the limit as capital T goes to infinity of the integral from 0 to capital T of e to the, this will essentially be a minus s or s minus a. Let's do a negative and then s minus a times t dt. So I've just added the exponents together to combine it as one exponential. Taking this integral, we're looking at the limit as capital T goes to infinity. We would have negative 1 over s minus a times e to the negative, in parentheses, s minus a, and then times t in that exponent, evaluated from 0 to capital T. This is the limit as t goes to infinity. We would have negative 1 over s minus a times e to the negative s minus a times capital T. And then we would subtract a negative 1 over s minus a times e to the 0th. This limit exists only if s minus a is positive, right? Otherwise, our exponential function will blow up or just be constant. So this limit exists only if s minus a is greater than 0, or in other words, s is greater than 0, sorry, greater than a. And so and then in that case, we get, so that first part would go to 0, and then we would have plus 1 over s minus a if s is greater than a, or just 1 over s minus a, again, for s greater than a. So we get that the Laplace transform of e to the at is defined as 1 over s minus a, and it's defined on s greater than a. Again, it's otherwise undefined. So this is finding the Laplace transform by hand, evaluating the improper integrals. In the next video, we'll go ahead and take a look at a table of Laplace transforms in which someone else has already done the calculus for us.